Good morning, my awesome mathematicians. Today we're going to be looking at benchmark percents and we're going to be estimating benchmark percents. And so the first thing that we want to do is we're going to look at a few problems, starting with, I love how we're able to model stuff. I think modeling helps us just understand a lot better sometimes what we're doing, and using color I think helps as well. So what we're going to do is you're going to need your book, and we're going to start on page, let me get this situated a little bit better. Sorry about that. We're going to start on page 385, okay? And on page, I'm just going to tear this out so you can see this better. So on page 385 at the top, it talks about a definition of what benchmark fractions and their corresponding benchmark percents are. And it says that they can be used when estimating part of a whole. Some common benchmark percents are 1%, 10%, 25%, 33 and a third percent, and their multiples. So that's what we're going to look at. We're going to look at models using these benchmark percents and fractions. And so the first thing it says to do is for you to label the bar diagram with the multiples of the benchmark percent 25%, okay? And with its corresponding benchmark fractions, the fraction like 1/4, and then the multiples of that. And so that's what we're going to do. So we would have 25%, we have 0, start at 0, 25%, and then that would be 50%, 75%, and 100%, okay? And then for the corresponding fractions, if you have 1/4, then this next part would be 2/4, which would simplify to 1/2. And then you would have 3/4 and 4/4, which would be 1/2. Okay, then they took it a step further and said, hey, let's, write the decimal equivalent to these percents and fractions. So here you've got 25 hundredths. Here you would have 50 hundredths, 75 hundredths, and you would have 1/2. Be sure that when you're writing your decimal, I know that I haven't said this, or I don't remember saying it to you guys this year, but be sure that when you have a decimal that you are putting a 0 in front of it. It's kind of like a red flag saying, hey, watch out, here's a decimal down here. You might not see me, but I'm down here. So pay close attention, and I won't take off for it, but it's a really, really good habit for you to get into. And I did set up your quiz where when you put your answers in, if you put the 0 in front of the decimal, it'll take it. If you don't, it'll take it as well. So it says, how can you check for accuracy of your model? I had to have a little drink of my coffee. How can you check for accuracy of your model? Well, one thing we can do is we can notice that that the parts are all the same size, right? And you know that these are multiples of 25%, right? And the multiples of 25%, I'm going to put multiples of 25% and their equivalent fractions and decimals. I could have said use multiples of 25%. with their, with their equivalent fractions and decimals. Okay. Now, it says, how can we extend the model for multiples of 25% greater than 100%? So if we continue, they're just saying, what would happen if you continued this past 100%? Okay, well, you would end up with 125%, right? And then you could go with 150%. 175%, and it could just keep going, couldn't it? And then you would also have there, this is a good point. So the fractions would end up being mixed numbers because it would be greater than one whole, greater than 100%. So the fractions would be mixed numbers until you would get to like 2, and then it would be, a whole number. But like those would be mixed numbers. The decimals could be extended as well. With 1 and 25 hundredths, 1 and 50 hundredths, or you could even say 1 and 5 tenths would be better, right? 1 and 75 hundredths, and it would just keep going. Okay, very good. So let's look at the next page. Page 386 would be on the back. So at the top here, it's showing you that you've got part of a whole can be estimated by representing benchmark fractions, benchmark fraction percents on a bar diagram or a double bar line, a 10 by 10 grid. You can solve the percent problem using models. So you've got a variety of ways that they're going to show you how you can solve your benchmark percent problems, or solve your problem, but using benchmark percents and fractions. So first, they're talking about that 27% is close to 25. So your benchmark percent would be 25%. So you would have your strip diagram. We would have 100%. And then if you know that you're doing 25%, we know that it would have to be divided into 4 equal parts. And so you would have 25%, 50%, and 75% labeled there. Now, they're saying that 100% is 200. So we would need to divide that into 4 equal parts. When we divide 200 by 4, we end up with 50. So we know that that's going to be 50. This next mark would end up being 100. This would be 150, and your total is 200. So the part that corresponds with 25% would be 50. And so about 50 people in the neighborhood are younger than 18. Where did we miss that problem? Is that on the front that we didn't read? Oh my gosh. Oh my gosh. Okay. This is what we were supposed to have been looking at the top. It says, how can about 27% of the population in Texas, of Texas is younger than 18. There are 200 people that live in a neighborhood. About how many of those people are younger than 18? And so this was our way of finding that answer. Remember that estimating is just it's an about answer. It's not a precise answer. So the second method, model 2, is going to be with a number line. So 27% of 200 is close to, once again, it's close to 30%. They're rounding up this time. 30% is a multiple of 10. So the benchmark percent is 10%. The benchmark fraction would be 1/10. So it says to draw a number line, label the benchmark percent and its multiples. And so that's what we're going to do. They did 0 to 200 on the bottom. That's with actual numbers. On the top would be 0 to 100%. So if we had 10%, then we would go 20%, 30%, 40, 50, 60, Norman's barking, 70, what's a percent? 80%, 90%, and then you've got your 100%. And then on the bottom, because it was 200, and we know that 10%, we have to divide it by 10, right? So 200 divided by 10 would give us 20. So we know each section is 20. So then that would be 40, 60, 80, 100, 120, 140, 160, 180, and then that gets you to your 200. So it says locate the part that corresponds to 30%. So if you see right here, 30% would be 60. So 30% of 200 is 60. So 27% of 200 is about, remember this is an approximation, is about 60. All right. Okay, now here you've got your 10 by 10 grid model. It says you can use this to estimate a part of a whole. Each column represents the benchmark fraction 1/10 and the benchmark percent 10%. Okay. I'm going to just underline and the benchmark percent 10%. So it says since 27% is about 30%, you're going to shade 30% or 3 columns. And so I'm going to use my very special, I have my special colored pencils. These are, yeah. And so I'm going to shade 3, 1, 2, 3 sticks of 10. So what I like to do is I like to outline it and then go back and completely fill it in, so I don't mess up. I mean, it doesn't have to be perfect or anything. It's just we want to be able to see it. And you want to be sure that you do shade correctly so you don't mistakenly, think it's a different amount. All right. Okay, so each column represents 1/10 of 200, which is 20, right? And so 27% of 200 is about 3 times 20 or 60. Okay. So if we're going to analyze this at the bottom, it says, explain why using different benchmark percents resulted in different estimations of 27% of 200. Okay. And so remember that 27% can be approximated to 25% or 30%. So a different benchmark percent will result in different estimations. So with the top one, we went with the 25%, ended up with 50. This one, we rounded up with 30% and ended up with 60. So we know that that 27% is going to be between 50 and 60. 50 and 60 people. I was about to say, what are we talking? We're talking about people. Okay, so I'm going to put 27% can be approximated. To 25% or 30%. So a different approximation, or a different, sorry, benchmark percent. Whoops. Benchmark percent. I'm writing off the line. Sorry, y'all. Benchmark percent will result in different estimations. Okay. Now, let's go to the next page, page 387. On page 387, this, I know it says work with a partner, but we're going to do a few of these together and then just make sure that you're understanding them. So on page 387, you've got on number 4, you have 10, you've got 0 and 10%, and they've shown you 1/10, and they've shown you the number line, and they're wanting you just to complete it. Okay, pretty straightforward. The same thing on all 4 of those at the top, and so you know if it's 10%, it's going to be and it's 1/10, you're going to have 10 equal parts. If it's 1/5, you're going to have 5 equal parts. So that denominator is going to tell you how many parts your whole is divided into. That's really important what I just said. That denominator is going to tell you how many parts are in your whole. Let's write that down. The denominator tells how many parts are in the whole. Okay. So if you want to take a moment and do some of those, you can do some of those for practice. But we do want to move on to our other page that we have. And that is looking on page, in your book, on page 300. Page 389. Page 389 is estimate using benchmark percents. And this is the same thing that we were just looking at. It says 52% of 298 is close to 50% of 300 because Josefina surveyed 298 students and found that 52% like scary movies. About how many students like scary movies? So it says draw and label a bar diagram to represent how the benchmark percent, 25%, and its multiples can be used to find 50% of 300. So that's what you're going to do. And so we're going to draw a bar diagram. Okay. And we know that the whole thing would be 100%, right? And we know that it's got to be out of 300. They want us to use our benchmark percent, 25%. So that tells me that I'm going to have to divide it into 4 equal parts, right? So I'm just going to eyeball it and go, that looks like the middle, right? Then that looks like the middle. And that looks like the middle of that side. Okay, so this would be 0%, 25%, 50%, and 75%. Oops. And then we said that that's 300, right? And so if we took, what's half of 300? It's like half of $3, right? Wouldn't that be $1.50? So wouldn't that be 150 for half? Then what's half of 150? What's half of $1.50? Wouldn't that be 75? Wouldn't that be 75? Be like 75 cents. And this would be 75. What would that be? 225. My brain is tired. Okay. So it says about how many students like scary movies if we're looking for 50%. About 150 students. Okay. Same thing here. They wanted you to do that. So we're going to move to the next page. Okay. And all of this that we've been looking at is just how to estimate part of a whole. So estimating the percents will provide a reasonable solution to many real-world problems. You can estimate part of a whole by representing benchmark fractions and their multiples on the bar diagram. And so that's what they're wanting you to do with all of these. So on this first one, you've got estimate 47% of 692. That's close to 50. That rounds to 700, right? 25% times 2 is 50%. So the same thing. They want you to draw, well, that's a bad drawing. This would be 100%. And your 100% would be your 700 that we've estimated, right? And then you've got your 50%. Half of 700 would be 350, okay? So about 47% of 692 is 350, okay? So that was kind of easy, wasn't it? All right. So I want you to, I don't really see, after doing that first lesson, I really don't see, you do need to be sure that you look at these examples. You've got extra practice ones that you can look at to work. Let me go ahead and do this one. 48%, the first thing you want to do is you want to round, okay? So step 1 is going to be, let me write that over to the side. Step 1, you're going to round. So we're going to round 48% to 50%. 76, I would round that to 80, because then that would make it really nice and easy to figure out, wouldn't it? So what's 50% of 80? You can draw your strip diagram. You might even know that half of 80 is 40, right? And there's your answer. So you're going to round the percent and the number, the whole amount. And then you can use your strip diagram to find your answer. Does that help? Okay, and just think about what's going to be the most reasonable, the easiest to work with. All right, so you've got, on page 392, you've got problems 1 through 6, and on 393, you've got problems 1 through 7. And you've got some examples, an example there on the back too. So be sure, if especially if you need to, go back and be sure and you read all this. I just don't want to make this video any longer than it already is. Okay, I hope this makes, hope it's easy to understand. And I will see you guys later.